Hello everyone. So today we are going to work on detecting hits and reacting to the hits for the punches in this hand-to-hand combat game that we are developing with C++. So here is the preview. So if the character do a punch like this, the opponent wouldn't react because it is too far, but if it moves closer like this, the character reacts. So everything is done in C++. So let's see how to implement this today. And this episode is sponsored by these generous patrons. Thank you very much for your support. Right, so far in this C++ series we have implemented punching animations and kicks, but still the other character don't recognize the hits, so he doesn't react to any kind of a reaction for the hits. So I have imported this reaction animations. I have 3 animations. Which one should I use? Okay, let's use this one. So first let's open the C++ file of the character, which is this one. So we have this implemented this check punch and check kick functions in the fighter using this fighter interface, but I don't think we have, we haven't implemented the functionality yet. So for now all I have done is check in punch and check in kick. We did up to this point in the previous tutorial, and we call this check punch and check kick from the events that we have defined in each hit animation. So let me show you. Here we have kick R event, and in the punching here we have this punch R event. So if I go to the animation blueprint, we have kick R and punch R. So we call check punch using fight interface on the character class, on the pawn, that means in this case the pawn class, the relevant character class. Okay, so when we call this, we actually call the function that we have implemented through this fight interface, and we have implemented the fight interface in the CPP character header file, like this, and we have added the relevant properties, relevant functions in this section with the suffix of implementation for check punch and check kick. So here we need to really implement that function. So let's get started with the check punch implementation. So first here what I am planning to do is, when this punch happens, I'm gonna get the location of this right hand and check that location and the distance from this location to the to whatever the body part of the opponent. So at the moment we don't have a variable for opponents, so I'm not going to dynamically detect the opponent, because this is going to be a two player thing, two character thing, where are not going to be many enemy characters. So they're like in Mortal Kombat, there'll be just two characters. So therefore I'm going to define a variable to set the opponent reference in here. So let's try adding another view property, edit anywhere, blueprint, read write, category, let's say, let's call it scene references. I guess that name makes sense. We have two brackets, and this, the other variable should be in the type of CPP character. I'll name it opponent, and it should be a pointer. Yeah. Okay, so if I build this, I should be able to set the variable in Unreal. Looks like build is going to take forever. Let's cancel this and do a rebuild. Right, build succeeded. Did it load here? Okay. I have to do extra compiling here to get it working, but anyway, now we have this opponent variable, so we can't set it here. Or we can from the example map, right? But this is not exactly the player. So here, select the player, and where is that option? Okay, here, scene references. Under that I'll select enemy, and so for the enemy character, under scene for the opponent, where is it? Scene references. Okay, I select player. Right, now let's go here and we need to get, so this is, if it is left hand we need to get the left hand bone location, if it is right hand we need to get the right hand bone location. So here I'll define vector 3, sorry, not vector, f vector. Vector hit location. Now let's call it hand location. So then is left hand is true, that means we are punching with the left hand. We need to get we can assign this hand location like this, mesh get bone location. Here we need to give the bone name. Let me check. Hand R. Okay, hand R and hand L. And L, and the space, bone space type. I'll give world space, and the next thing, yeah, that's all we need. What's the error? Member is inaccessible. Okay, then we should have a function to get mesh, right? Oh, it is working. Okay, so this is if it is left hand. Else, oh wait, else we should do the same thing but with hand R. Right, now however we will have a location in this hand location vector after this part. Then we can find the closest bone location of the opponent based on this location. So for that we gonna need, opponent is also going to be a CPP character. So let's define a new method called let's call it fname get closest bone vector location, and another float mean distance. So what I'm planning to do here is this. So using this get closest bone location, I'm gonna give the attacker's hand location or the foot location based on if it is a kick or a punch, and then mean distance means the minimum distance, now let's call it max distance. If one of the bones has a lesser distance from this location of the victims, one of the bones, I'm going to count it as a hit. Let me explain again. If one of the bones of the attacker of the victim has a lesser distance than this defined distance to this location, I'm going to count it as a hit. Okay, right, we can implement this function here. After, well, kick or punch, well, I'll implement it after this function. No, I think, okay, here, right here, first I'll get a list of bones. Get no. So this is the way I'm going to use this function. Fname hit bone samane equals get closest bone, and as the input I'm gonna give and location, and as the max distance I'm gonna give 20. Like this. So we would have a valid name as the hit bone if we have a valid hit. So let's implement this get closest bone. Oh wait, I have to call this function on opponent like this, because we are checking with the opponent if the opponent get hit. Right here we can implement get mesh, get bone names, and the result of this is wait, let me check. Get bone names TRA fname. Okay, and we have to give TRA fname as bone names. Okay, so TRA fname bone, let's call it bone names. Do we need a pointer here? I'm not sure, but let's see. And let's give an bone names. What's there? Right, this is how it should be. TRA fname bone names, and just put bone names as the input of this one. Though this "and" is actually, it's just a hint from the editor, so this is not really typed there. Okay, now let's to make sure that I need to make sure that I have the bone, all the bone names I need loaded into this one. So let's do a for loop for actually we can auto generate this for right like this. As the upper I can use bone names num, returns the number of elements, and here I'll just do add a screen message just like this, so that we can print all the bone names in green, and as the text I'll put name sorry, not fname, bone names oh, it's not like this. We can just use born names and delete born names I to string. Yeah, this should work. So for now, just to not to have any errors, I'll just return nothing, an empty string like this, and let's build just to check if we get the born names printed into the screen. It didn't hot reload. Let's save everything just in case if anything crashes. Right, the function is working. That's why I got printed all these born names. Okay, we are progressing slowly, very slowly, but we are learning. Good. Right now I'll add the two more variables, f name closest born and float min distance. Let's just call it min dist, easier. And as the minimum distance, I'll put a very large value like 10,000. And I don't need this, so I'll comment that part. Now we need to calculate the distance between this current born that we get here and this location. So how do we do that? Let's do f name p name equals born names I oh, we don't really need to do that. We can just do get mesh, get born location, and as the born name I can just give born names I, and as the space born spaces world space, and that's it. And we can put this in f vector born location. Now we can calculate the distance between this born location and this location. Shall we rename this to as hitborn or something? Yeah, let's call it hitborn location. That's clear. So if main dist is larger than, how to calculate distance between two vectors. We do have a function called f vector dist. Right, now we can give two vectors. So first one is hit bone location and the other one is bone location. So if this mean distance is larger than the current distance between the current considering bone location and the hit bone location, then I'm gonna set main dist as whatever the value we get here. Maybe we should have another temporary value. Let's call it temp dist, temporary distance. Dist equals temp dist, and closest bone equals whatever the current bone. That means bone names I. Okay, now just like this we will get a bone name. So here instead of nothing, an empty string, I'll return closest bone, and before that I will add a print here. To print the closest bone. Right. Okay, build. Build succeeded. And let's play. Ring high. Okay, so pinky ring, so we get the closest bone like that. Awesome. Now now we have this max distance. So let's see, if main distance is less than max distance, we can return the closest bone. Otherwise we have to again return an empty bone name to say that, actually can we return? No, oh, we can't. Let's just return it like this, and let's do the print here. So we will get the print only if we have a closer bone than the given max distance. So if I do a punch here, we still get it. But how? Let's see. Did I do anything wrong? I think my if condition is wrong. Yeah. Well, let's type the minimum distance here as well. Maybe it didn't compile previously, or maybe I don't know. Let's see what the value we have in the min distance. So we can print the min distance variable like this: f dist f string sanitize float min dist. Right, build, and hot reloading doesn't happen, so let's compile and let's play. Okay, now when we punch we didn't get the print, but when we go closer, alright, now we get the closest born name printed. Okay, so we get a valid born name. That means we hit the character. So now let's go back to here, the check punch implementation. If hit born not equal to this one, that means we have a hit. So we can call some function on opponent to react. So yeah, we actually haven't implemented any function to show reaction yet, so let's add another function. Let's call it void punch react, and yeah, let's build it. Okay, this place seems alright. So all we have to do is plain some montage. So a montage. Oh, sorry, we don't have a react montage yet, so let's add one, just like this. Wait, I'll copy this part, it would make things easier. Let's call it m punch react, and here I'll just play it, m punch react, play rate is 1 and name none. So this part says which section of the montage to be played. So actually I need to play it from the beginning, so name none would do. Alright, compile. Now we need to assign a montage for the reaction. Okay, now m punch react, we got it here. So let's create a montage with this. Oh, no, I created a composite. Sorry. Create and a montage. Okay. So I'll also enable root motion here so that the character will not move while this is happening. And assign hit reaction montage. Right, now we need to call it punch react. I think we didn't call it here. Okay, opponent punch react. Okay, build hot reload sound heard, so it should be working. Okay, right. Actually, reactions should be faster, so maybe blending time, let's make it 0.1. No. Okay, or we can in the punch animation which animation I have used, this one. We can pull this a little bit backward so it should match. Still no. Right, then we can go here, reaction montage. Let's increase the play rate. Oh, that's too much. Let's try 1.5. Okay, right, that's better. Right, so I imported these sound effects, these punch sounds and some hurt sounds, grunt sounds and some swoosh sounds. So let's play. How to play in the animation itself? Let's add some hurting sounds. Or should we do this in the code itself? Well, for now I'll just play the sound here. It's not that important at the moment. As the sound effect, I'll use hurt sound like this, but the punch sound, let's play it in the beginning. Play sound. And this swoosh sound, I'll do that in the punch in montage. like this. Okay, now let's see. Right. Right, now it feels much better. Okay, so I'm gonna stop this episode right here. And as always, project files will be available for the download through Patreon page. Link would be in the description below. And thanks for watching. See you in another episode. Goodbye. And also, if you like to support my work, you can get the membership of the Patreon club. And goodbye again.